Welcome back to the deep dive. Today, we are undertaking a really critical mission, plunging into one of the most rigorous and, frankly, most aggressive theoretical battles that's currently shaping how we understand the brain.
It's a big one.
It is. Our focus material for this deep dive has been meticulously curated by Professor Rubens Godoy Sampaio, and it lays out this monumental, direct confrontation. We are looking at the clash between his framework, TUMCA, which is the unified theory of memory, consciousness, and learning.
In the model that's become increasingly dominant in computational neuroscience, Karl Friston's Active Inference, or AI.
Exactly.
And you're absolutely right. In our previous discussion, we did the structural comparison. We mapped out the architecture of both systems. On one side, you have TUMCA, which asserts that memory is the single foundational biological mechanism for all cognition.
The one and only building block.
The one and only. Versus Active Inference, which anchors its entire framework in this one mathematical law, the free energy principle, or FEP, as the necessary condition for life itself.
So today, we're moving past that comparison. We're stepping directly into Professor Sampaio's core philosophical assault.
Right. Our mission today is to really dissect his argument against what he calls the hypostasis of the free energy principle.
Hypostasis. That's a word we're going to be hearing a lot.
We are. And the crucial claim here is that the FEP isn't some breakthrough in cognitive theory, but that it's actually perpetuating a deep historical philosophical error.
That is a staggering charge. To suggest that the mathematical rigor, the sheer complexity of active inference is built on a fundamental mistake that's centuries old. It's pure intellectual combat.
It is. He's essentially putting the FEP in the same category as obsolete scientific concepts like phlogiston or the aether.
Wow. Okay, let's unpack this. We should probably frame this whole discussion like a courtroom debate. First, active inference presents its mathematically stunning evidence for its own existence. And then Sampaio steps forward with his defense of parsimony.
I like that. So let's start with the target. What is the grand unifying appeal of the FEP that makes it so potent and, so tempting to reify in the first place?
Let's set the stage for the takedown.
Active inference, primarily championed by Friston and his colleagues like Parr and Pizzullo, offers something that philosophers and neuroscientists have been searching for centuries. A single, unified, normative framework.
It's not just describing what happens, it's prescribing why it has to happen that way.
Precisely. It's a proposed law that doesn't just describe cognition, it dictates why biological systems behave the way they do. And the scope is just breathtaking. It claims to govern perception, attention, decision-making, movement, even your immune response, all under one single mathematical umbrella.
It really is an attempt at a grand theory of everything, but scaled down to the level of the individual organism just trying to survive in a chaotic universe.
You've hit on it exactly. The core mandate of the FEP is presented as a fundamental biological necessity. Living organisms must, at all times, continuously minimize surprise.
And we should be clear, surprise here isn't, a surprise party. It's a very specific mathematical concept.
A very specific one. Mathematically, it's the negative logarithm of the evidence for the system's sensory observations.
Which, for those of us who aren't mathematicians, basically means the system has to work tirelessly to prevent anything unexpected from crossing its sensory boundaries.
Exactly. Imagine the organism is trapped behind this semi-permeable boundary, its sensory manifold. It has to ensure that the observations coming in align with what the organism expects to observe. This is the core imperative for what the theory calls self-evidencing.
Proving its own existence to itself, moment by moment.
Yes. The system remains a stable, living entity. It is what it is, only as long as its sensory inputs stay within its characteristic states. You can think of that as, a preferred body temperature, stable blood sugar, enough oxygen.
The physiological comfort zone.
The comfort zone. If the system fails to minimize this surprise, if its internal model of the world and its own body fails spectacularly, the theory is very blunt. It becomes a corpse. Survival is literally the continuous act of proving, moment by moment, that your own existence is predictable to yourself.
That makes the FEP sound less like some abstract principle and more like a mathematical definition of life itself. It's the ultimate statement of homeostatic control.
It connects directly to that historical concept of homeostatic equilibrium, but the FEP really elevates it beyond simple mechanical feedback loops. Minimizing surprise over the long term is equivalent to minimizing the entropy of the system, keeping disorder at bay.
But in complex organisms like us, that requires more than just reacting. It demands proactive behavior.
And that's the crucial shift to what's called allostasis. Homeostasis is simply responding to thirst by drinking water. Allostasis, as the source material beautifully illustrates, is engaging in far-sighted, open-ended, novel behaviors like finding and purchasing good wine to satisfy that core imperative of minimizing future thirst and ensuring physiological comfort over a long, long temporal horizon.
That distinction is key. Allostasis requires sophisticated prediction and planning, which is where the FEP really claims to shine, by unifying the mind and the body. But we need to get a bit more technical for a moment. How does the FEP actually do this? How does it execute this minimization goal computationally?
Well, this is where the math comes in. Since calculating the true surprise of every single sensory input is basically computationally intractable for any complex system, it's just too hard to know the true probability of everything.
Right, the universe is too big.
It's too big. So active inference introduces a proxy, the variational free energy, or VFE. The VFE acts as an upper bound, a sort of easily computable stand-in for surprise. The organism's entire perceptual and cognitive process is then reduced to a continuous effort to minimize this VFE.
Okay, so the VFE is the objective function. It's the score the brain is constantly trying to drive down to zero.
Precisely. And this minimization carries a really deep philosophical interpretation, which is often linked to the principle of parsimony, or Occam's razor.
Oh, okay.
The system isn't just seeking any explanation for its sensory data, it's seeking the best explanation. And in the VFE framework, the best explanation is the one that achieves the optimal complexity-accuracy trade-off.
It has to be accurate, so it has to explain the data coming in, but it also has to be simple. The internal generative model it's using to make predictions can't be unnecessarily complicated.
That's it. I like the analogy in the source. It's like the brain is a tax accountant trying to find the simplest, most efficient filing strategy for a flood of confusing financial data. It has to be accurate to the receipts, but it must use the fewest possible lines on the form.
A perfect analogy. So that's how the VFE governs perception, what the theory calls inference. It's about updating beliefs and correcting prediction errors.
Yes, that's the heart of the predictive coding mechanism. It's about minimizing VFE in the present.
So that covers the now, how we perceive the world. But what about the future? How does active inference handle complex, goal-directed planning? That's the allostasis part.
Right, so that shifts our focus from the VFE to the expected free energy, or EFE. The EFE is what the organism minimizes when it's choosing a future sequence of actions, what it calls a policy. It's a perspective measure, looking forward.
And the mathematical elegance here, I gather, is how it breaks down.
It's beautiful, really. The decomposition of EFE is what resolves that classic dilemma in behavioral ecology, the exploit-explore trade-off.
The famous split. Do I stick with what I know works, or do I risk trying something new to see if it's better? How does EFE formalize that tension?
EFE breaks down into two core components that guide all future behavior. First, there's the epistemic value. This is the part that drives exploration.
The drive for knowledge.
It's the inherent motivation to seek new information that resolves uncertainty about the world. If your internal model is uncertain about what's around that corner, minimizing EFE creates an incentive for you to go look.
And then the other half?
The other half is the pragmatic value. This is what drives exploitation. It's the classical utilitarian drive. Selecting actions that are expected to lead to preferred outcomes, maximizing utility, getting you back to those known, comfortable states.
So active inference doesn't see exploration and exploitation as two different systems fighting for control. They're just two sides of the same mathematical coin, the same EFE minimization equation. That's incredibly elegant. It's a totalizing framework.
It is. It uses the organism's subjective generative models, its internal hypotheses about how the world works, to constantly refine perception and choose these optimal, self-evidencing actions. So given this mathematical richness, this ambition, this ability to unify perception and action, you can really see why active inference has become so influential. It truly seems to be the first real contender for a theory of everything in biology and cognition.
Okay, so we've established the case for the prosecution, so to speak. Active inference is mathematically rigorous, it's ambitious, and it unifies all these biological processes under the FEP. It presents itself as the most sophisticated explanation we have.
The state of the art.
State of the art. But the moment we start treating this beautifully defined mathematical structure as a real thing, a necessary causal entity, we step right into Professor Sampaio's trap. So now let's bring in the defense. Let's dig into his aggressive philosophical argument for parsimony.
This is where the critique takes a very hard turn. Professor Sampaio argues that active inference, by promoting the FEP from a description of optimal system dynamics to the actual necessary motor or principle that causes life and cognition, well, he says it commits this ancient fundamental error of hypostasis.
Which he calls the Furia Hypostasiadora, the rage for hypostasis.
That's the one. It's the complete and utter reification of an abstract concept.
Reification. So, putting it simply, that's turning an idea into a concrete substance. It's making the abstract real.
Exactly. It's transforming a useful, logical function, like VFE, or an explanatory construct, like the generative model, into an autonomous, substantial entity that exists separately from the underlying material, the biochemical reality of the brain.
So Sampaio's position is that the FEP isn't a causal principle dictating how things work. It's just a mathematical tautology.
Exactly. A necessary truth about any self-organizing system, not the thing that makes it self-organize. It's a description, not a cause.
So the FEP is being used, whether they mean to or not, as a new kind of ghost in the machine.
Precisely. And this leads directly to a completely redundant duplication of reality. When active inference talks about the organism operating with internal models or internal representations,
Sampaio says that's just a fancy way of saying something much simpler.
much simpler. He says these are nothing more than our prosaic memories, simple, mundane memories about how to interact effectively with the world. Why introduce a new, incredibly complex concept like a generative model, a formal Bayesian structure, when a vastly simpler, evolutionarily older, and universally accepted biological function, memory, already does that job?
This is where the condemnation by William of Ockham comes in.
This is Occam's razor, weaponized. Sampaio is essentially screaming. You are multiplying entities beyond necessity. You don't need the complex machinery of variational calculus to explain why a baby reaches for a bottle. You just need the memory of previous successful attempts.
He has that great quote from medieval philosophy.
He does. Lapis non est in anima, said species lapidus.
Which means?
In English, the stone is not in the soul, but the idea of the stone. The schematic economical representation of the world, the idea of the stone, is what exists in the cognitive system, not a perfect one-to-one duplicated model of the stone itself.
And that schematic representation is memory.
It is memory. Sampaio sees the whole AI postulation of a small-scale model of reality. This model the organism uses to simulate and test alternative actions as the ultimate error of duplication. That supposed model is just the body of schematic, economical, simplified memories the organism has built up over its lifetime.
So to introduce the FEP to drive the optimization of that so-called model is?
In Sampaio's aggressive phrasing, it's just duplicating reality and making William of Ockham tremble in his grave. The burden of proof lies heavily on active inference to demonstrate why its computational principle is necessary when memory provides a much more parsimonious alternative.
That is a powerful, powerful theoretical challenge. And if Sampaio is right, if he can show that the FEP is redundant, then he has to place it among history's great scientific errors. What's the company the FEP keeps in his pantheon of non-existent entities?
He is not subtle here at all. He compares the postulation of the FEP, and by extension, the concept of consciousness is trying to explain directly to these huge theoretical constructs that science had to completely abandon because they created unnecessary complexity to cover for a flawed central premise.
Let's walk through his historical parallels because they are absolutely crucial to understanding the weight of this critique. Where does he start?
He starts with phlogiston. This was the hypothetical element that was supposedly released during combustion.
Right. And it seemed to work for a while. It explained why things burned.
It did, but to make it work, it required all these complex rules and bizarre properties, like sometimes having to have negative mass. The whole concept was rendered obsolete and just vanished once Lavoisier introduced oxygen and the principle of mass conservation.
So the FEP, like phlogiston, is this theoretical entity that's been invented to explain an observation, in this case self-organization, but it actually adds complexity instead of reducing it.
Precisely. The second parallel is Ptolemaic epicycles.
Ah, the classic.
The classic. In the geocentric model, the planets sometimes appeared to move backward in the sky. That's retrograde motion. To save the flawed central premise that the Earth was the center of the solar system, Ptolemy had to invent this incredibly complicated mathematical machinery.
The planets moving on smaller circles, the epicycles, which were themselves moving on larger circles, the deference.
An absolute mess. And this is where the analogy gets really interesting for the FEP. Active inference relies on extremely complex mathematics, variational calculus, differential equations, generalized coordinates of motion. Sampaio is suggesting that this entire computational machinery is the modern equivalent of the epicycles.
Wow. So the math is only necessary because the foundational assumption is wrong.
That's the key insight. The math of VFE and EFE is only necessary because of an incorrect foundational postulate, the FEP itself. If you start with a faulty premise, the Earth is the center, or the FEP is the necessary motor, you have to introduce these increasingly complicated mathematical corrections to make the data fit.
Just like the epicycles. But then Copernicus comes along.
And he fixes the solar system by just changing the center. He puts the sun there, and suddenly the geometry simplifies dramatically. The epicycles aren't needed. Sampaio believes that by placing memory at the center of cognition, the complexity of the FEP becomes similarly redundant and unnecessary.
And his third parallel, the ether.
The ether. The hypothetical substance that was supposed to fill all of space, and it was only considered necessary because 19th century physicists believed light had to travel through a medium, like sound travels through air.
But then Einstein showed that light speed was constant and didn't require a medium.
And the ether vanished overnight. It was gone. Sampaio was essentially saying, the FEP is the ether of cognitive science. It's a hypothesized principle of minimization needed to fill the explanatory gap between the physical brain and the abstract mind. But if you look closely at the brain's fundamental function, which is memory, that gap just dissolves.
To call the FEP ether, that is not a subtle critique. Sampaio is basically accusing Friston of building a beautiful mathematical spaceship based on faulty 19th century physics.
Yes, and that leads directly to his critique of the whole computational metaphor itself.
The idea of the brain as a computer.
Exactly. Active inference relies so heavily on the language of computation. Bayesian optimization, algorithms, generative models, optimal computation. Sampaio just sees this as perpetuating a really tiresome historical trend.
Where the brain is always compared to whatever the most sophisticated machine of the era happens to be.
Always. Before, it was the Greek biga, the chariot, then it was clockwork automatons, hydraulic pressure systems, telephone switchboards, and now it's Bayesian networks, or maybe even quantum computers. Sampaio argues that comparing the brain to a quantum computer is just the 21st century update of Plato, comparing the soul to a chariot. It fundamentally misses the biological reality.
So if the problem isn't computation, what is the core nature of life that he thinks the AI framework misses?
He proposes that life is fundamentally historical, not computational. The stability, the permanence, the capacity for reproduction and adaptation. None of that is the result of some discrete algorithm running on an instantaneous processor.
It's rooted in processes that unfold over time.
Exactly. Genetic memory DNA and learned memories. The system persists not because it's perpetually calculating some Bayesian optimal state, but because its current state is the historical accumulation of every single past interaction it's ever had.
That makes the organism an archive of its own past, rather than just a calculator of the present.
It's an archive. And that archive is memory. So when AI uses a highly technical term like internalizing models, Sampaio argues that the essential, simple concept is being obscured by all this mathematical complexity.
So what's the TUMCA translation for internalizing models?
It's simple. Schematic, economic, and abbreviated memorization of something in the world. That's it.
So all the complexity of the differential equations, the generalized coordinates of motion, he's saying none of that actually adds any essential explanatory value. It just adds these unnecessary mathematical layers to a simple biological process.
That's the crux of the linguistic purification Sampaio demands. Why use a phrase like minimizing the expected free energy over a policy space, when what you're actually describing is the memory system proactively prioritizing actions that lead to anticipated, comfortable, and predictable states?
It's the difference between elegant mathematics and biological parsimony.
It is. The whole critique boils down to this. Active inference is mathematically compelling, but it's fundamentally inefficient. It's philosophically flawed, and it's biologically unnecessary if you just take memory seriously as the central organizing force.
Which brings us to the alternative. If we've successfully dismantled the FEP and we're ready to place memory at the center, how does Sampaio's theory, TUMCA, solve these persistent philosophical problems of consciousness, intelligence, and language with nothing more than a simple biological function?
This is the constructive part of his argument. This section presents what Professor Sampaio calls the Copernican revolution of the brain. For millennia, the central mystery of the mind has always been consciousness, the reflective, subjective I.
Right. And memory has traditionally been seen as a secondary, almost mechanical role, like a storage locker for consciousness to access.
A servant function. Exactly. The classical model puts consciousness at the center, and memory is just a tool. Sampaio completely flips that astronomical model. Just as Copernicus moved the Earth out and placed the Sun at the center, TUMCA removes consciousness from that central position and installs memory in its place. Memory is the primordial, most complex, and most necessary function of the brain for survival.
And the radical implication of that shift is the definitive reductionist thesis about consciousness itself.
The core thesis of TUMCA is uncompromisingly simple, and it's this. Consciousness does not exist as an independent entity in itself. It is merely a differentiated use of a single brain function, memory.
So there's no structural difference between the experience of remembering something and the experience of being conscious of something.
None. The distinction is only one of degree of intensity, of vividness, of immediate focus, not one of fundamental nature.
That immediately dissolves the hard problem of consciousness, doesn't it? If the difference is only one of degree, you don't need to find some magical bridge between matter and mind.
It dissolves the hard problem by calling it a false problem. Sampaio posits that it is impossible to be conscious of anything without remembering something. When you are conscious of the light coming through the window right now, that consciousness is simply your sensory memory functioning intensely in the present moment.
And if you lose your memory?
If you lose your memory, and not just your episodic memory of what you had for breakfast, but a foundational capacity to hold and retrieve traces, you lose self-consciousness. We see this dramatically in cases of profound amnesia, like with Clive wearing. Memory is the necessary condition for the possibility of consciousness.
Okay, so if consciousness is just a specialized use of memory, what is the specific biological mechanism that generates that subjective feeling of reflection, the loop that creates the sense of I?
That mechanism is recursivity. In TUMCA, consciousness is defined as the recursivity of memory. Memory folding back on itself or remembering other memories. It's the cognitive looping, the self-referential feedback circuit that makes us aware not just of the world, but of our awareness of the world.
And Sampaio uses this wonderful, simple metaphor to illustrate this point, which completely bypasses the need for complex mathematical formulae like the FEP.
The paper airplane metaphor. It's perfect. The relationship between consciousness and memory is exactly like the relationship between a paper airplane and the sheet of paper it's made from.
The airplane, which is consciousness, isn't made of a fundamentally different material than the paper, which is memory.
Not at all. Its complexity, its ability to fly, its emergent function, it's all due entirely to the foldings, the recursivity of the sheet upon itself. The material substrate remains memory. The emergent phenomenon is just the result of the structure imposed by that self-reference.
And the beauty of this concept is that recursivity isn't some magical thing unique to the human mind. It's a fundamental biological principle of self-organization.
Absolutely. Sampaio emphasizes that recursivity is everywhere in living systems, which demonstrates its evolutionary validity. We see it in the initial development of an embryo, where the neural tube forms by the folding of embryonic tissue back upon itself. Our entire sensory system is recursive, with higher cognitive centers feeding back predictions and modulations to early sensory processing areas.
Even the immune system.
Even the immune system operates recursively. A fever is the body acting on itself to accelerate its own metabolism and white cell production. And physically, our bodies are recursive. Our arms can touch our backs and our feet. It's a fundamental design principle.
The implication for cognition here is huge. The recursive process is inherently load-reducing and makes things simpler, not more complex.
It dramatically decreases the computational burden. The recursive process allows for extremely rapid, complex executions based on a simple, self-referential procedure of evocation. Our intricate subjective life, our complex thoughts, our feelings, our planning strategies, is simply this dense, self-referential web of memories, recalling and interacting with other memories.
This is the crucial step, then. If we accept that memory is the core, we have to be able to demonstrate how it accounts for all the specialized functions we've traditionally separated into different modular boxes. Sampaio famously refutes the Swiss Army knife metaphor of the mind.
Yes, the modularity theories, like Jerry Fodor's, they treat the mind like a Swiss Army knife, a complex device with all these distinct tools for language, for spatial reasoning, for facial recognition, and so on.
And TUMCA rejects this entirely.
Completely. Memory is not a complex Swiss Army knife. It is a simple knife with a single, highly refined blade. And Sampaio's claim is that with that single blade, the brain performs every single function we mistakenly reify into separate executive or cognitive abilities.
Okay, so let's test that. Let's start with the functions we most often attribute to a separate processing center, like expertise and intelligence.
Right. Intelligence and expertise are simply the brain's capacity to rapidly and automatically evoke fixed memories after a long iterative process of learning. If you're an expert at something, you have internalized vast libraries of procedural and factual memories to the point where they're automatic.
So when a skilled mathematician calculates something like 2 to the power of 5,
They're not performing 5 separate multiplication steps in their head. They're instantly retrieving the fixed memory of the answer, 32. The speed of that memory retrieval based on these fixed procedures is what society mislabels as high intelligence or genius. It's not a special faculty. It's just highly optimized memory performance.
okay. And what about attention? Attention is often considered the gateway to consciousness, the spotlight. How does the simple knife of memory handle selective focus?
Attention in the TUMCA model is just memory operating in a concentrated, highly focused state. It's a memory system being occupied with only a small number of salient inputs or internal thoughts. Sampaio gives it a wonderfully vivid name for it.
What's that?
Slow motion memory. Memoria en cámara lenta.
Slow motion memory. I like that.
It's memory momentarily slowing down its operational speed and intensity to deal with something novel, something unexpected, or something crucial to survival.
Why slow motion, though?
Because when something truly new happens, say a strange sound in the dark, the brain can't rely on automatic, fixed memory retrieval. It has to devote its maximal mnemonic resources to that novelty to ensure that a new, relevant memory trace is encoded as quickly and accurately as possible,
So the goal of attention is ultimately to learn the new thing.
so that the required response becomes automatic and ordinary. It becomes just another fixed, easily retrieved memory in the future. And distraction, conversely, is just memory being used diffusely across too many items at once, which reduces the intensity of its function on any single point. Attention and distraction are merely variations in the intensity and focus of that one underlying memory function.
That completely eliminates the need for a separate attention network or a global workspace in the Fedorian or Dehenian sense. It's all just about the intensity settings of the memory system.
Exactly. And finally, language, the one cognitive function that seems to separate us most definitively from other animals.
Language is often seen as the ultimate specific module, requiring specialized algorithms, grammar rules, syntax structures. How can memory alone possibly handle the complexity of human communication?
Well, languages fundamentally depend on memory, obviously, for the names of things, their semantic relationships, the rules of their order. But more importantly, Sampaio defines speech as a form of abbreviated behavior,
A shortcut.
a very powerful shortcut that replaces complex physical actions.
Let's explore that idea of abbreviated behavior with a concrete example.
Okay, so consider the act of requesting a simple drink. If you're in a restaurant and you want a coffee, you don't have to perform this long, complex sequence of physical actions. Get up, walk to the kitchen, mime picking the beans, grinding them, boiling the water, and pouring it into a cup.
You'd be thrown
You'd
out.
be thrown out. Instead, you use the verbal command, waiter, a coffee. That short verbal phrase is a highly efficient, learned abbreviation for that entire, extensive physical sequence.
And the only reason that abbreviation works is because both your brain and the waiter's brain share these vast, complex memory structures about the world, the words, the objects, and the procedures involved in making and serving coffee.
If memory failed, communication would collapse into an infinite mime show. The power of language is that it allows the brain to store and retrieve these complex action sequences with incredible economy. And furthermore, language provides the ultimate externalization of memory through writing, which allows human culture to transcend the limits of the biological brain, granting our collective memory a kind of perennity and autonomy.
The unification of all of these functions under the single banner of memory leads to a radical rewriting of our philosophical foundations. What happens to the Cartesian, I think, therefore I exist?
Well, if thought and reasoning and planning and consciousness are all just fluid, continuous uses of memory, then the entire foundation of cognition has to be shifted. That famous dictum must be replaced with the TUMCA foundational principle. I remembered that, therefore I think, lembro logo penso.
Memory is the ultimate cause and condition of thought.
It is. This represents the ultimate demotion of the thinking ego. The self is no longer some special, separate psychic entity floating around in the brain.
So what is the self, then?
The self, the ego, our personal identity. It's all reduced to the intricate, interwoven, and highly organized collection of our autobiographical memories, each associated with varying emotional intensities. If you remove the memories, as these devastating neurological conditions sometimes do, the self simply dissolves. The implication is profound. Your identity is made of the same substrate as any other mundane memory trace. It's not a separate entity. It's just the paper, folded and organized in a particular way.
And Sampaio extends this same monistic reductionism to our experience of time itself, arguing that time also isn't some independent entity.
That's right. He draws a fantastic analogy to physics. The relationship between consciousness and memory is like the relationship between time and movement. Time, for Sampaio, is not a separate entity out there waiting to be measured, like Newton believed. Time is the procedure of counting or measuring change. It's our conventional way of observing motion.
And without memory, the human experience of time, the subjective sense of past, present, and future, is impossible, because any sense of sequence requires retaining the previous state.
That's impossible. And so what are past and future then?
Just classifications.
They're just classifications.
Yeah.
They're not ontological entities that are inherent in nature. They're merely linguistic categories that we use to organize different types of memories. The memory of a trip you took last year is categorized as past. The memory of a trip you plan to take next year, which is based on fixed procedures and expected outcomes, is categorized as future. Both are ultimately just memory traces being evoked and manipulated by the exact same underlying biological mechanism.
So by installing memory at the center, TUMCA achieves this profound parsimony. It collapses the dualistic problems of mind-body, attention-consciousness, and even the nature of time into a single evolutionarily coherent explanation. And it entirely bypasses the need for an abstract governing principle like the FEP.
Let's synthesize the core difference now that we've explored both sides. Active inference provides a structure that is mathematically magnificent. You have variational Bayes, generative models, optimization principles. But its conceptual architecture is expensive. It requires the hypostasis of the free energy principle as a necessary, overarching causal entity to explain biological persistence and cognition. And that costs it parsimony.
And Sampaio's TUMCA responds by saying that expensive architecture is completely unnecessary. The solution is already built into the oldest, most fundamental component of the brain.
Precisely. TUMCA offers a radically biological and evolutionary solution. It integrates seamlessly with Darwinian thought. The vast gap that we perceive between us and other animals is not defined by the sudden appearance of a magical FEP or some immaterial soul.
It's defined by an incremental, quantitative increase in memory capacity and the efficiency of its recursive uses.
That's it. It wasn't a qualitative jump. It's not like a new processor was installed. It was a quantitative one. We just got a slightly bigger hard drive and faster retrieval speeds, which allowed for more complex recursive folding.
And that small quantitative difference allowed for the explosion of complex behaviors like robust language, advanced tool use, and crucially, the ability to externalize memory through writing.
Yes. Writing depositing memory onto papyrus or stone or computers grants that memory perennity and allows it to operate autonomously outside the limitations of the biological system. And this fundamentally changes the scale and the speed of cognitive and cultural development.
This requires a change in terminology, though, and Sampaio is quite firm on the need for this kind of linguistic purification.
Absolutely. He argues the next crucial effort, if you follow the TUMCA path, must be a necessary logical linguistic purification. We have to cease using these vague, reified concepts like mind and consciousness because they imply a separate existence. Instead, we have to explicitly articulate the centrality of memory and detail how this single function, through its differentiated uses and its recursive structure, performs every function we mistakenly categorize as distinct executive abilities.
So essentially, swapping out the word mind for memory in our explanatory vocabulary and then getting to work defining the detailed mechanics of that memory.
Which means the neurobiological research into memory, which is already a very mature field, is the explanation for consciousness. We don't need a separate search for the neural correlates of consciousness. The processes that constitute the phenomenon we call consciousness are simply the well-understood neurobiological processes of memory. Sampaio would argue the hard problem is a non-problem, a philosophical mirage that results from misnaming and hypostatizing a fundamental biological function.
This entire debate is a profound example of how philosophical parsimony can challenge even the most complex, mathematically rigorous scientific theories. It forces us to ask that fundamental question: is your explanation truly necessary? So as we wrap up this deep dive, what final provocative thought does this confrontation leave us with to mull over?
I think the final reflection has to be this. The path to understanding ourselves is not necessarily paved with the creation of highly complex new mathematical constructs like the FEP, which, as Sampaio argues, risk repeating the errors of phlogiston in the ether. The true breakthrough may require us to take a deliberate step back and instead observe, with fresh eyes, the most fundamental, oldest, and most frequently neglected function of the living brain, the memory. And if consciousness is just recursive memory, does that mean every moment of reflection, every time you feel that unique sense of self, is merely your brain momentarily diverting power from external tasks just to check its own internal hard drive? It really forces you to re-examine the very material nature of your own identity.
That concludes our rigorous deep dive into the theoretical confrontation between the unified theory of memory, consciousness, and learning, TUMCA, and the principles of active inference. A truly fascinating look at how simplicity and biological necessity can challenge even the most elegant mathematical descriptions of existence.
Indeed, we appreciate you joining us for this intensive exploration of consciousness, computation, and what may be the ultimate primacy of memory.
And remember that this specific material, produced with the rigorous curation of Professor Rubens Godoy Sampaio, is exclusive to the subscribers of Philosophilic's.